Hi everyone, today we are talking about graphing tangent and cotangent graphs. We just did the notes for the cosecant and secant, and now we are moving on to tangent and cotangent. Alright, for graphing tangent we need to know a few things. First, like every other function, it's built from the unit circle. One key difference though is that the period of tangent is going to be pi, so anytime you need to find the period of tangent you use pi over b. Okay, let's look at the parent function for tangent. If I'm going to graph tangent, I need a little table of values here. If I know, that the period of tangent is going to be pi for this basic y equals tan x function, then I can assume I'm either going from 0 to pi or negative pi over 2 to pi over 2. But let's take a look here at the tangent function and see where we're headed. So let's start with 0. The tangent at 0, at this point 1 comma 0, is going to be y over x. That's going to be 0. The tangent at pi over 2, which is the point 0 comma 1, is going to be 1 over 0. So that is going to be undefined. The tangent at, let's go with negative pi over 2, is going to be 0 comma negative 1. That's going to be negative 1 over 0. That is also undefined. And so what we're looking at here, let's look at the tangent of pi over 4 and pi over 2, or pi over 4 and negative pi over 4. The tangent here at square root of 2 over 2 comma root 2 over 2, the tangent would be 1, so that would be at pi over 4, the tangent would be positive 1, and at negative pi over 4, the tangent would also be positive 1. And so what we see when we start to graph this is that we do in fact have a period of pi from negative pi over 2 to positive pi over 2. At pi over 4 and negative pi over 4, we've got tangent equaling negative 1 and positive 1 through 0, 0. And now these vertical asymptotes happen at negative pi over 2 and positive pi over 2. And so the tangent function follows this general pattern. A few things to note if you're thinking, oh, this looks like x cubed. You're not wrong. It looks like x cubed, but there is one key difference, and that is that there are these vertical asymptotes that the tangent function hugs, and x cubed does not have any asymptotes. Okay, so we're going to look at the graphs and their relationship to the origin. The basic tangent function is centered on the origin, and it goes from negative pi over 2 to pi over 2. That'll be true, at least the centered part, for tangent. Tangent is very symmetrical, so we're going to start at the origin and then graph it, unless it's been moved left or right, but we'll talk about that when we get to that. To graph tangent, you're going to first find the period, find your key points, figure out how the amplitude plays in, and then sketch your asymptotes and then your middle 3 points. So when I look at this first example, the amplitude is 4. There are no horizontal or vertical shifts with this tangent function, and I'm going to find that the period is pi over 1/3, which means that the period is 3 pi. So I'm going to be taking a look at this tangent function with a period of 3 pi, right there. Half of 3 is 1.5, so that's 1.5 pi, right? 3 pi over 2, and then negative 1.5 pi, 3 pi over 2. If we mark these halfway values, well, if we think of this as 6 pi over 4, we think of this as negative 6 pi over 4. We're going to be looking at 3 pi over 4 and negative 3 pi over 4. Here are the vertical asymptotes for this function. I go through 0, 0, and the tangent goes low to high. So because the amplitude is 4, my low pass-through point is down here at negative 4, and my high pass-through point is up here at positive 4, and the tangent function looks like this. That is the graph of 4 tan 1/3 x. Stay tuned on the next video for the next example of negative 2 tan 3x.